Now let's move on to creating one-dimensional and two-dimensional arrays with Numpy. But first I'm going to give you a short overview. So Numpy is short for numerical Python, and it works primarily with numerical data. So a one-dimensional array is like a grid of values. It's like a list, and similar to a list, it is ordered mutable and it's enclosed in block brackets. One of the differences is that the values in a Numpy array needs to be of the same data type. So now a two-dimensional array is like a list of lists. It's arranged in rows and columns, and the 0-axis represents the direction of the rows and the 1-axis represents the direction of the columns. The benefits of using Numpy arrays over lists is that they can be stored more efficiently, and they're useful when working with large amounts of data. So let's create a 1D array. But before we do that, we need to import the Numpy library. So we do that by import Numpy. And since we don't want to type out this whole Numpy word every time we refer to a function in Numpy, we write as NP. So now we always only use NP when we're calling Numpy functions. So let's run that. And you see everything is fine. So now let's create a list and then convert it into a Numpy array. So I'm going to create a variable li, and our list is 1, 2, 3, 4, 5. Then I'm going to set li to np. We'll call it what we imported Numpy as, np.array. And in brackets, we put our variable. And now let's call our variable. And you see it is an array. Let's see the type. And you see it gives us a Numpy one-dimensional array. Let's look at the shape of this. And one way we could look at the shape, we type np.shape, and in brackets, we put our array. And let's run that. And this means that there are 5 elements in each row, but it is a one-dimensional array, so there's only one row. A better way to do this is just by calling our variable period shape. Let's run that, and we get the shape of our array. We can also create an array by just passing a list into our function. So np array, and our list could be 6, 7, 8, 9, 10. Let's run that, and you see we have a Numpy array. Another thing we can do is turn a tuple into array. So np.array. In our previous lessons, we know that a tuple is surrounded by brackets. And let's run that, and you see it is an array. Now let's move on to creating 2D arrays. And let's create a variable called rnp.array. And then we're going to put our two-dimensional arrays. 2, 2, 2. When creating two-dimensional arrays, we need to put it in a nested list. So we need to surround all of this with block brackets. So we put one here and one here. And now let's call our array. And you see we get a 3x3 matrix. On the 0-axis, there's 3 rows, and on the 1-axis, there's 3 columns. Let's look at the shape. The first arguments represent the 0-axis, which is 3, and the second argument represents the 1-axis, which is also 3. Let's make some changes. Delete this, run this cell, and run this cell. And you see on the 0-axis, we have 2 elements, and then the 1-axis, we have 3. Let's pass in variables with stored lists into the array function to create a two-dimensional array. So let me Copy this here, bring it here, set li2 to 6, 7, 8, 9, 10. And now let's pass in our variables into our function. So let's create a variable, array2, np.array. I'm gonna pass in our li variable and li2 variable. And now let's look at that. Oh, we need to surround this with block brackets. Now let's run that. And you see we got our two-dimensional array. Let's take the shape. And you see we have 2 rows and 5 columns. The 0 axis is 2 and the 1 axis is 5. Let me go through one more additional topic. This is a 1D array. So R1, set that equals to np.array. Let's put in a list, 1 on 1. And I want to say this is a 2D array. I want to set R2 to np.array. And I'm also going to set 1, 1, 1, 1. If we want this to be a 2D array, we need to make it a nested list. So we do that by putting it inside block brackets. So now let's run that. And let's look at the shape of R1. And it tells us that it is a one-dimensional array with 4 elements in 1 row. And now let's check the shape of our 2D array. And you see it tells us that it is a 2D array because the 0 axis is 1 and the 1 axis is 4. Let's take a look at it. And it's a nested array. Welcome, I hope all is well. And we're gonna go over slicing and indexing in Numpy arrays. So first we're gonna index a 1D array. So let's create an array. Create a variable, np.array. In brackets, we put blocks and we put our values. Now let's call out our array. And you see here we made our array. So if we want to index, let's say we want to get the 7th value, we will just type in the index position inside of block brackets. So 0, 1, 2. And this is in the second position. Let's press. And you see we get 7. Let's get 0, 1, 2, 3, 4, 5. It's in the 5th position. If we want this 3, we would have to put 0. So now let's move on to slicing. And similar to this, we use the start, stop, and step position inside of square brackets. So now let's do that. So let's say I want from the 0, 1, 2, 3, 4, from the 4th index to the rest of my lists. R2, colon, and we leave that blank, which means that it's going to get the rest of the values in the list. And you see we started from the 4th position. Let's say I want from the 6th to the 8th. So the 6th is in the 1st position. And the 8 is in the 0, 1, 2, 3. And it's in the 3rd position. But with the stop value, the index is exclusive. So 0, 1, 2, 3. We would have to actually put 4 here. Because in the stop argument, the indexing is exclusive. So let's run that. And you see we got what we wanted. From the 1st position to the 4th. If we want, we could also reverse the array by putting a -1 step. And let's run that. Oh, we need to add our stop, and our stop So we're getting everything in the array, but we're just reversing it with a -1 step. Let's run that. And you see it's reversed. So now let's move on to slicing in a 2D array. I'm just going to copy something I already have and paste it in. And this is a 2D array. So let's look at that. Then you see we have our 2-dimensional array. So index and slicing in 2D arrays requires rows and columns index. So R2. And let's say we want this 50, 0, 1. So it's the index position of 1 and the 50, 0, 1. And this will also be 1. And let's run that. And you see we get the 50. Let's say we wanted to get the 69. 0, 1, 2. The index position is 2. And the column is 0, 1, 2, 3. Let's put 3 and we get 69. Let's do some slicing examples. So R2. And let's say we want to get the last row. We would start from the 0, 1, 2. From the index position 2, we put our colon and we leave it blank because we want all the remaining from position 2, but we don't have any more, so it's going to bring the last row. So 0, 1, 2, and then the next argument is the columns. So we said we want all the columns. So to do that, we just put our colons and we don't put anything in front or behind it. And let's run that. And you see we got our last row. Let's get the first row. So our first row is in index position 0. So we want to start from 0. And remember, the stop argument, it's exclusive. We would have to put 1 if we wanted this last row, because if we count 0, 1, the stop argument is exclusive and it will bring back this first row. So now let's run that. And for the columns, we're going to leave this because we want all our columns. And let's run that. And you see we got the first row. Let's say we want from index position 50 to down. We would count our indexing 0, 1, 2, 3, 4. And we leave the stop argument blank. And let's run that. And you got 50, 37, and 4. Let's say we want from 0, 1. 1. Let's say we want from 6 to 8. So the index position is 0, 1, 2, 3. It's exclusive, so we will have to put 4. Remember, at the right side in the colon, the stop position is exclusive. So we want 8, 0, 1, 2, 3, but we have to put 4. So from 6, 7, and 8. And let's run this. And you see we got 6, 7, 8. Let's say if we want this row and this row. So we start 0, 1. So we'll erase this. And we want to start from our 1. And we're going to leave it blank. And it's going to get the rest of the rows in the array. And then I said we want from here to here. So the index would be 0, 1, 2, 3. So let's put 3 right here. We're starting from 3 and we're gonna go down the rest of our columns. So let's run that. And like I said, we got these values here. Let me do one more example. Let's say we want to get the middle row. We would start with 1 and we want to end at 0, 1, 2. So we'll put 2 here, but it's going to bring up our 1 index because the stop is exclusive. This is highlighting row 2 or 0, 1, the row in the 1 index. And then let's remove this 3 to get all the columns in that row. So let's run that. And you see we got it here. Let's say we want to get 52 to 20. So 0, 1, 2, 3, 4, 5. And we put 5 here. The start index is not exclusive. So let's run that. And you see we got those two values here. So now let's move on to Boolean array indexing. First, let me copy this. Let me just change this to 1. And let's run that. So let's create a conditional statement that returns a Boolean array. So we put R1. Let's put more than 3. And let's run that. And you see where, so 3 is not more than 3, so we get a false, and all the rest of these values is more than 3, so we get a true. We can also filter out to only bring the values that's more than 3. And so we do this by surrounding this by in block brackets and putting our variable in front. And let's run that. And you see it only brings the values that's more than 3. So the same with a 2D array. R2, let's look at that. Let's do conditional statement. R2 is more than 10, and it will bring us true and false values. False where it's less than 10, true where it's more than 10. And now let's only extract the values. And let's run that. And you see a flattened 1D array is returned when we filter Boolean array. So let's look at the shape of this. Let me just copy it, paste it. Let me write dot shape. And we see it tells us that it is a 1D array with 12 elements. We can reshape it back to a 2D array with the reshape function. So let me paste this, dot reshape. And in between brackets, we put the amount of rows and columns that we want. So let me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to give this 2 rows and 6 columns. And let's run that. And now you see our array has been reshaped. Now let's move on to array manipulation functions. And the first function we're going to go over is the reshape function. As you see here, I put a one-dimensional array into an x variable and a two-dimensional array into a y variable. Let's look at x. Let's look at the shapes. And you see our x is a one-dimensional array with 10 elements, and our y is a 2x5 matrix, or 2 rows and 5 columns. So now let's use our reshape function, and let's reshape our 1D array to be 2 rows and 5 columns. So let's run that. And you see we took our 1D array and we turned it into a 2D array. Let's look at the shape. And you see the reshape function changes the shape of our 1D array. Let's try to shape it back into a 3x3. So x dot reshape 3x3, and we will get an error. Let's run that. And we got this error because we can only reshape an array to a shape that will fill the array. So a 3x3 won't shape an array with 10 elements. We could do 5x2, and that should work. And here you have it. Now let's move on to the flatten function. And the flatten function converts a 2D array into a 1D array. So our 2D array is y. Let's run that. And now let's flatten that. And let's run that cell. And you see we converted our 2D array into a 1D array. Let's look at the shape. Let's run that. And it's a 1D array with 10 elements. Now let's move on to the transpose function. And before I do that, I want to create some more variables. A equals so I'm creating a 2 by 2 matrix for A and a 3 by 3 matrix for Y. I mean a 3 by 3 matrix for B. And let's look at A. Our mistake here is we didn't nest. It's missing some. We need to surround this by brackets. And let's run that. And you see we got our 2D array. Let's see the shape. And you see it's a 2 by 3. Let's look at B. Let's look at its shape. And it's a 3 by 3. So let's look at our A again, and we're gonna transpose this. So A dot transpose, and let's run that. And you could see the rows has been transposed to the columns. Let's check the shape. And it should be, and you see we have 3 rows and 2 columns. And up here before it was transposed, we had 2 rows and 3 columns. And the transpose, we flipped that. Now let me add another list here. And let me run that. And now let's look at B again. And it's a 4 by 3. Let's look at the shape. And you see 4 rows, 3 columns. And now let's transpose that. Let me just copy this. Paste it here. B. First, let's look at the transpose. And you see it's been switched. Let's look at the shape. Let's run that. And you see it gives us the shape of our array after it's been transposed. Now let's move on to array creation functions. And the first functions we're gonna go over is the full function. And we can use the full function to create an array and fill it with a specific value. So let's create np.full. And the first argument takes the matrix that we want. So I want a 3 by 5. And the next argument is what you want to fill it with. So let's fill it with 8. And let's run that. And you see we made a 3 by 5 Numpy array. Let's have some fun. Let's do a 10 by 10. And we want to fill it with 9, 9. And here you have it. The next function I want to go over is the arange function. And the arange function can create a one-dimensional array with even space values. So let's create a range. I want it to start from 0 up to and not including 20. And then I want it to go by 2s. So let's run that. And you see it started with 0 up until but not including 20, and it's going by 2s. If we want 20, we go one more higher. And you see we got the 20. Let's count from 0 to 100 by 10s. Let's run that. Actually, we said 100. So we want 110 here. And you see we counted from 0 to 100 in tens. If we want, we can reshape this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me make this 10 values. Let's run that. And then we can, if we want, we can reshape this 1D array. So let's reshape. And we want 2 rows, 5 columns. Let's run that. And you see we got 2 rows, 5 columns. Now let's move on to the rand function. With the rand function, we could specify the shape and populate the array with random values. But those random values are only between 0 and 1. So let's write np.random. Then we have to type .rand. And let's populate a 5 by 5. And you see we made a 5 by 5 matrix with values between 0 and 1. Now let me show you another function called randint. And with the randint function, if we pass a lower bound as the first argument, the upper bound as the second, and the third is a tuple for the shape of the array. So let me create np.random.randint. And the first argument takes the range. So I want numbers between 5 and 20. And then I want it to be a 5 by 5 matrix. So let's run that. And you see we get a 5 by 5 matrix with random numbers between 5 and 20. So these are some array creation functions. Now let's move on to mathematics in Numpy. So I'm going to import Numpy and run this cell. And I'm just going to paste some arrays that I already made. So we can add arrays that have the same dimensions. So let's call out our array, R1. And let's run that. Oh, I need to run this cell. So run this, and then run this. And then you say we added our array. Another way we can do this is with the numpy add function. So add, and we put in the arrays that we want to add. So let's run that. Oh, I'm supposed to put numpy.add. So let's run that. And you see it does the same thing. And we can also add multiple arrays together by just adding one more. Let's run that. And you see we can add as much as we like. When adding arrays, the one axis should be the same. It needs to be the same to be broadcasted. So let's try this. Add array 1 plus array 2, and we'll get an error. But since array 3 and array 1 has the same rows, we can broadcast array 1 to array 3. So let's run that. And we see array 3. We broadcasted array 1 to array 3. Let's take a look at array 3 and array 1. And you see 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 4 equals 7. 3 plus 5, 8, and so on. The same with the second row. 1 plus 6 is 7. 2 plus 4, 6. 3 plus 3, 6, and so on. So we broadcasted array 1 to array 3. We can also add scalar values. So let me just take a look at my array. Let's say I wanted to add 10. Let's run that. And we added 10 to all of our elements in the array. Let's say we wanted to add or find the sum of all the elements in array 3. We'll write np.sum, and in between brackets we put in our array. And let's run that. And you see the sum of all these values equals 63. Let's look at our array again. And let's sum all the elements on the 0 axis, meaning that the columns will get summed up. So we put np.sum, and then we put in our variable, and the next argument we put in the axis equals 0. And let's run that. It's supposed to be np, and let's run that. And you see it summed up the column. So 2 plus 6 is 8, plus 2 is 10. 3 plus 4 is 7, plus 3 is 10. 4 plus 3 is 7, plus 4, 11, 5, 5, 5, 15, and so on. If we want to sum up the rows, we put np.sum R3, and we set the axis to 1. Let's run that. And you see 2 plus 3 plus 4 plus 5 plus 6 is 20. this row, if we sum up this row, it will be 21. And if we sum up this row, it will be 22. We can also find the mean of the values in our array. So array3 dot mean, and let's run that. And you see the mean of the elements in our array is 4.2. Let's find the mean of each column. np dot mean our array3, and the next argument, the axis equals to 0. And let's run that. And you see the average of each column. Let me just copy this so we can find the mean of each row. And we just change that to 1. And let's run that. And you see we get the average for each row of elements in our array. Let's call in our array3 again so we can watch it. And let's say we want to get the maximum of each row. We would write np.amax. We call in our array, and we said we want the row, so we set the axis to 1. And let's run that. And you see we get the max value for each row. So the max value here is 6, 6, 8. Let me copy this, paste it here. Now we want for the column, and let's run that. And you see the max of the first column, 6. This one here is 4, 4, 5, 8. We can also do the a min. So I'm just gonna change it here. Let's run that. And you get the minimum value in the rows. Now let's get the minimum value for each column. Let's run that. And you see we got that minimum values.